Today I am going to talk about solution of nonlinear equation, means how to solve nonlinear equation. Now first must know what is nonlinear equation. A nonlinear equation is an algebraic equation in which the variables are raised to power other than 1 and are multiplied and divided by each other. In contrast to linear equation in which have a constant rate change and form straight line when graphed. Nonlinear equation have a varying rate of change, typically form curve graph. Now general form of nonlinear equation. The general form of a nonlinear equation is fx is equal to 0, where fx is a function involving variable x and possibly other constant or parameters. Nonlinear equation can have multiple solution or no solution at all. Solving nonlinear equation often requires numerical method or approximate techniques, as closed form solution may not be readily obtainable. Now example of nonlinear equation. Example of nonlinear equation include quadratic equation, cubic equation, exponential equation, trigonometric equation, and system equation with nonlinear term. Nonlinear equations are encountered in various fields of mathematics, physics, engineering, economics, and other sciences, where they are used to model complex relationships and phenomena. Now, how to solve nonlinear equation? So there are many methods to solve nonlinear equation. Here, generally two categories methods are available, are there. One is bracketing method, another is open-ended method. Now first, what is root? Now suppose if you plot that nonlinear function, suppose the function is y is equal to fx is equal to fx. Okay, now if you plot x and y x axis and y axis, okay, now suppose the function is like that. Suppose this is fx. Now this function cut the x axis in certain points. Let's say this is x1. So x1 is called root of the function, where if you take f of x1, that will give 0 or nearly equal to 0. So x1 is the root of the equation. Now I told you there are two types of method to solve nonlinear equation. One is bracketing method, another is open-ended methods. For bracketing methods, again two types of methods are there. One is bisection method, another is regular falsy method or fault position method. For open-ended method, again we have another two categories. One is Newton-Raphson method, another is secant method. Now I'll go one by one. First, bisection method. So now what is bisection method and what are the algorithms? The bisection method is a numerical root finding algorithm that works by repeatedly dividing an interval in half. Here is the summary. Suppose given an equation fx is equal to 0, an interval a and b where fa and fb have opposite signs. Suppose maybe fa is positive or fb may be negative or vice versa. Then bisection procedure can be applied. The bisection procedure as follows: commute the midpoint. If a and ab is the opposite sign, then commute midpoint c of the interval, so that c is equal to a plus b by 2. If c is equal to 0, if c is equal to 0, then c is the root of the equation. If c and fa have opposite signs, update interval to a to c, otherwise update the interval to c to b, and repeat that procedure 1 to 3 until the desired level of accuracy is achieved. Now this is the algorithm. Now I'll show you how to solve by bisection method, how to solve nonlinear equation by using bisection method. Now here I'm taking fx, one nonlinear equation, that is fx x cube minus 2x minus 5 is equal to 0 in the interval of 2 and 3. We have to find the root of the equation. Now first we must compute fa and fb. Here fa, if you compute, so that will be 2 cube minus 2 into 2 minus 5, so that will give minus 1, so negative sign. And FB, so that is 3 cube minus 2 into 3 minus 5, so that is 16, positive. So root lies between interval 2 and 3. Now, so here evaluate FA, so that is negative, and evaluate, so this is 3, F3, so that is 16, positive. Now coming with the midpoint C, so C will be 2 plus 3 by 2, 2.5. Now evaluate FC, so 2.5 q minus 2 into 2.5 minus 5, so that will give positive. Now here f of 2 and f of C means 2.5 is the opposite sign. So since fc is negative, that update interval to C to B, right? C to B means, or C is actually 2.5, B is 2, or maybe we can write 2.5 to 2. So this is the interval, and you have to repeat that procedure to get desired accuracy level. Now I'll explain in details here in the table. Okay, so this is our function. Now first, this is the iteration number. So first iteration, a is equal to 2, so now we have to calculate f2, that is minus 1, negative. At b 3, so f3 is 16, positive sign. So root lies between a and b. So now that midpoint, by using bisection method, so C will be 2 plus 3 by 2, 2.5, and we have to find out what is function value at C point, C. So that is f 2.5, so that will be positive value. Now this is positive and this is negative. So root lies between 2 and 2.5. Again 2, the function value is minus, negative, 2.5, so 5.625 positive. So that midpoint of that two interval, two value, midpoint, so that is 2 plus 2.5 by 2, so that is 2.25. Again 2.25, so that will give 1.89, again positive value. So this is positive, this C give the positive value of the function, A means 2, that will give negative value, means that will be opposite sign. So root lies between 2 and 2.5. Again 2, that is minus 1, negative, and 2.5, that will positive. Now again by bisection method, so midpoint will be 2 plus 2.5, so that is 2.125, and at that point that function value is 3.3457. Okay, you can do the calculator, but do the calculation. If you use the calculator, we can easily get that function value at 2.125, so that is 0.3457, that is positive value. Again root lies between 2 to 2.125. So root lies between 2 to 2.125. So now this is give negative, that means at A the function value is negative, at B function value is positive, so midpoint will be 2 plus 2.125, so that is 2.0625, and that function value here is the 2 at 2.0625, so that will be negative. So this is negative, okay, and this is positive. So root lies between B and C, means 2.125 to 2.0625. Here 2.0625, so that is negative, 2.125, that is the positive. So midpoint, so that will be 2.0938. Now if I calculate what is the function value at 2.0938, so that is give negative. Now here that is 8.94 e to the power minus 3, so it is a nearly equal to 0. Or if we go for a few more steps, okay, so this is negative and this is positive. So now next step, that root lies between 2.125 and 2.0938. Now here after 5 iteration, so that bisection method converges to an approximate root of the equation. In this case the approximate root is 2.0938. At x is equal to 2.0938, that function value is nearly equal to 0. So that is the root of the equation, root of the function. That's it for bisection method. So again next I'll talk about fault position or regular faulty method. Thank you.